Next slide, please. If anyone has listened or seen one of my presentations on stormwater parks in the last 6 years, well, I've used this one every time. This is it's been a shout out to the work that Courtney and I have done starting in 2017, taking a few years off for pandemic and sabbatical reasons. Now we're right back at it, doing the Pima Water Urbanism every spring. So we're just doing a deep dive today about this class. Okay, next slide. We picked real sites for the students to look at, and Courtney's gonna go through what the class involves. And what we wanted to do was pick real sites that have real opportunity for stormwater mitigation. And we started by looking at different land use typologies. We wanted to explore different land uses and how they could implement stormwater parks or stormwater mitigation. We all know public parks is kind of our main driver here. It's really the best place to get some of these infrastructures in. We've also looked at schools, maybe vacant lands, abandoned commercial spaces that could be rehabilitated, and of course our right-of-ways. And these are sites that I would select personally, and just because I knew the qualities of the space, and we would put these sites to the students for their use. Okay, next slide. ADAQ, we had to update our MS4 permit recently, and one of the responsibilities on us now is to plan and propose mitigation opportunities. And we told ADAQ that most of our urban spaces are within the city, so they're allowing Pima County to get MS4 credits of mitigation within the city. So we did a data analysis showing where are the places that need it the most, and these are the classic, what I'm calling now classic parameters that we are using to demonstrate that stormwater mitigation is best used when there's high imperviousness, industrial commercial space, high urban heat severity, high population density, low tree canopy scores, and where could we mitigate flooding at the same time. So we've broken it down into 4 groups of watersheds in the Tucson metro area: north, south, east, and west. We are not looking at our southern group. That's the Rita Ranch area. Rita Ranch area is fairly new, built out residential areas, and there is stormwater drainage infrastructure already in place because the standards are already there. So we really want to look at those older spaces to do these stormwater parks or mitigation strategies. Next slide, please. So this last spring, we started with the North group. So we wanted to make sure that we were looking at sites that had an opportunity for stormwater mitigation, and at the same time get credit for our MS4 responsibilities with ADAQ. That's, 2 birds, 1 stone. If we could get credit for that permit, great. And so we wanted to look at these MS4 watersheds and potential sites located within. This is our selection. This is our list of sites for this last semester. A couple sites, Flowing Wells Junior High, that was a site not selected by the students. We try to give them more sites than needed so that they have some selection power in what site they work on. My guess is Flowing Wells Junior High might have been too built out of a site. We don't know what the students, why they chose the sites and why, or they did not choose sites, but I think that's a powerful question for us to understand, what drives a young designer to want to work in a space. I think that's important. And then Thurber Road was a site that was selected, but at the end of the semester, they proposed that a stormwater park at that site would not be the best use of that site. I'm theorizing it may be a dense residential opportunity like apartments or affordable housing may have been a better use for that site. And we want to make sure that we get real valuable stormwater data to these sites for the students to actually see how the site works with stormwater. We're using Flow2D. If we have Flow2D data, then we get these maps to the students just so they could see, at least try to visualize how the water moves across their site. Next slide, please. Okay. And these are these are the locations of the sites for the last semester. These are all within or closely located to our northern group of MS4 watersheds.
And I think this is where we pass the baton, but then of course, like Jacob, please make comments while I go through some of the work. Basically, I picked out 3 sites, 3 of the projects. These are, like Jacob was saying, these are all the sites that we worked on this past year. So we have, I had a class of 17 students in the studio. And so they worked in pairs and one trio. The studio is a lot about learning about collaboration. In other parts of the curriculum, they only work as individual designers, but this is very much about like collaborating with each other, collaborating with flood control and other consultants, and expanding their sort of mode of thinking and with community engagement as well as a partner in collaboration. So the 3 sites that I'm going to talk about today is Habitat for Humanity, Halron Court, and Francisco Elias Esquire Park. I chose these because I think they're different enough so you can kind of get a sample, like even though, like Jacob said, they're all part of this MS4 grouping and some larger analysis that was done. And they're in land. So Halron Court and Halron Court is Pima County land. Francisco Elias Esquire Park is city-owned land. And then Habitat for Humanity is an interesting project. It's Habitat for Humanity owned land, but as with a lot of Habitat for Humanity parcels that are like donated to them, they usually have flooding on them. So Habitat is often in the need of basins with their affordable housing designs. The title of the presentation is, how this is useful for students and professionals. So I just wanted to say that really quickly. At least from the student point of view. I think Jacob can represent the professional point of view. But, I think it's really powerful for architecture students. And I think, it could seem like an unlikely combination, architects and hydrologists, working together. But for designers and teaching design, water is a really powerful medium to teach students a lot of important concepts. And so, one of those as architects is, wow, your, impervious land cover has a big impact on the city. not just on your site, but can have an impact across the city. And architects, since we've been building, have been having a really negative impact on our, on flooding in water collection. So I think, as myself as an educator, I think it's important. We're putting tools in students' hands to create all this impervious land cover, but I want to also be on the other side to emphasize sort of them to think more finely about sort of impacts they can have, and then also, as they are architects are often the project managers. They're the initial people usually looking at the design. Oftentimes, unfortunately, like landscape architects are brought in at the end when a lot of important decisions are already made. So I think it's important for architects also to have that kind of concept early on and to be sensitized to the idea that we can coordinate with, the civil engineers and flood control and landscape architects earlier in the process to get a much better product long term. And the other part of this is you'll see in the project students are doing some kind of community engagement, either with neighborhoods, but also we met with these projects are in Ward 3, so we met with Kevin Dahl, who's head of Ward 3, and got their feedback. Then students met with individual neighborhood associations. So they're also learning not just about their sort of like power as architects, but ways that they could have agency to have positive impacts, right? That they can go talk to their ward members and they can be civically engaged as they take on projects in the future. And then the last thing, of course, is this performance piece, like why Jacob and I are working together, because flood control gives, you'll see multiple iterations of hydrological modeling back to the students. So when they first design a site at the beginning of the semester, they learn they're not doing that, they're not doing as much as they thought they would be doing in a design, and then they have to make their basins bigger and bigger. And so it's this really nice feedback between Pima County and then the actual student designers to hone in on better and better designs and to understand also this idea of form, what something looks like versus performance. And that, that performance is for flood control, but it's also this social performance that you'll see, which is this idea, of course, in Tucson that we're working with basins that have multiple purposes, right? If the basin's really only going to be occupied, a handful or two of days out of the year, like what else are we doing with this basin? Like how else is it serving the community? And that's really the engagement that students are doing with neighborhoods. Like, what do you want to do with this land? Like beyond the stormwater park, what else can this land do for us? So with that, I will go forward with the Habitat for Humanity project. I'm gonna just try to like go through these slides really quickly, just so you can get a sample. I don't know how many, some of these are sort of more architectural kinds of documents. So I don't know how versed the audience is in reading these different kinds of drawings, but let me know if there's any questions or confusion. And then I'm going to sort of tell you in some of these drawings, like each project has certain drawings and why this is part of this greater kind of pedagogical outlook, collaboration between Pima County and the U of A, like why we're asking students to do different things. So Habitat for Humanity is a project in central Tucson. It's an interesting project. At first actually came to the Drockman Institute, which is our community outreach and research arm of our College of Architecture, Planning and Landscape Architecture here at U of A. And Habitat for Humanity is saying, look, we've mainly, our paradigm is single family home ownership, which in terms of form, what that looks like is usually a single house owned by someone. But as we know, housing prices have gone up. And so Habitat came to the Drockman Institute to say, we want to look at new paradigms. Like, how do we do shared wall construction? How do we do these more densely populated so we can house more people on the same amount of land? And so the house designs that you'll see here is actually Drockman Institute did the design for Habitat, but then the studio took on this lower third of the parcel for a stormwater park with the support of Pima County. And so this is a project that's actually slated to start construction in about a year. There's federal funding to fund it. So the students do lots of analysis early on. Like I said, water is a really powerful medium to teach design because it flows everywhere, right? So they are challenged to think outside of just, like a little footprint of a site. And so, one of the things we ask them to do is to do a network diagram where they're figuring out what kinds of urban networks is their site a part of. And so in this case, the students decided to kind of frame their work in terms of the other sites that Habitat for Humanity has across the city, and the kinds of green space access that those habitat sites have. And what they found out was that these other habitat sites have parks nearby, right? There's a lot of there's open space connections and like safe passage to these open space connections between these habitat sites. But this one in Mountain View neighborhood was actually quite isolated. And so the idea here is, Habitat was just going to make a big retention pond in the back, right, of this third of this piece of land. And so the students said, no, this is a great opportunity to make it more of a park, to make it more of this space for families that will be in these habitat homes. And they're doing just general analysis at the start of a project. This is Mountain View neighborhood. They're looking at who is around their site. Like you see here, that green arrow says it's 3/4 of a mile to the nearest park, and you can see some of the other stuff that's around the neighborhood. And then they're looking at, of course, the tools that our city and county and PAG makes publicly available, different resilience planning tools, looking at extreme heat, looking at green infrastructure priority zones, washes, flood risk, these different characteristics. And then this is a map, this is a graphic that the students made that's basically taking the Flow2D analysis that Jacob and his team provided to the students. So this is for a 100-year flood event. So you can see Navajo Road, also known as Navajo Wash, is there in like this dark blue because that's where a lot of heavy flooding occurs. And you can see how some of that water is flowing across the site. And then the housing layout that Habitat currently has. I also wanted to say, just that there are, since 2017, there's been so many different people involved, and many people on this call right now have been involved in this work. And so I wanted to say that, especially because, we're doing midterms and final reviews, and there's so many people who are coming in and putting ideas forth, like obviously Jacob, but also this semester Nicole Casebeer was there, Justin Walrick, and then Eleonora we're talking about coordinating with Evan Camfield next year. Blue Baldwin came in at midterm, and in fact, our faculty in the landscape architecture program too, and in the architecture program. So we have lots of people who are coming in to make these designs of high quality because they're giving the students really great feedback and great ideas. So I'm gonna make that clear. So just quickly, again, this is sort of the students then do on-site, we do it during a time of year where there's actually rain occurring at the beginning of the semester. So the students are going out there and actually watching the rain move, the water move across the site, and learning about that, again, from an educational perspective. And then, like I had said before, the students are asked sort of at midterm, once they've done one initial design and after they've met with the ward office, to then come up with a creative way to do community engagement, and either talk to a neighborhood association or different people. In this case, the students talked to Habitat for Humanity. So Charlie Buchanan and Jeff Ocamp, the CEO and COO of Habitat, were very involved. And then they also talked to sort of the youth population that lives in these sites, and had them the kids draw out different things that they wanted for the site. So, a playground was one of the main things. And then they pull out sort of the community led goals and strategies. And so, of course, reduce flooding is always, the big goal. But Habitat really emphasizes minimizing maintenance, maintaining affordability, because these are neighborhood associations, so they don't want to build anything that's going to be costly for neighborhood associations to maintain. Addressing demographics, and providing for green space. And one other feature before I start kind of clipping more quickly through these slides that I wanted to talk about that I think is a really important feature that Jacob and I have come up with over the years is this idea of the students design a low design and a high design. And what that is the low design is sort of a bare bones design with the basins and that addresses the flooding, but is ultimately low cost. And then on top of that, so they're nested. So they're not two separate designs. They're just like basically phased. So low design is phase one. So the students really need to think about affordability. And then the high design basically gives the students this sort of long leash to, imagine something totally different. So this is where I think flood control hits, if I can say that, Jacob, hits both of their goals, which is like a realistic design. And then they also want to see stuff. They're engaging with students to have fresh ideas and see things differently. And so that's kind of accomplished between these low and high designs. Students do a budget too. That's not so realistic, but at least is a pedagogical tool to have students itemize and think about how you really parse out like a low design and a high design, and you phase them together for sort of more civic projects that are really worried about a budget. So this is their bare bones design here. So they have one big basin in the center of the project, and then you can see the other ones are on the side. Maybe, I could let Jacob describe it if he wanted to. Jacob, do you want to say anything about the approach here?
Regarding the high design, I really enjoy that part of the equation. Not that I dislike our stormwater parks of current, but we got to, break the box. Let's just get some new, fresh ideas. What haven't we imagined yet? And I think that's what we're asking the students to do. But eventually there's going to be some basins, some swales, making sure the water goes from the right place to the right place. And ultimately we're driving elevation. Let's learn the geospace so that the water does work properly.
And that's great. Yeah, it's a lot of like students kind of learn by guess and checking with Jacob, I would say. Like their first designs, some of them hit it right on the nose and they understand intuitively water flow very well. And some of them, it takes a few iterations, but I think at the end of the semester they have much more of that kind of internalized sense of how water flows and what kind of design strategies work and the technical aspects too. So this is the master plan for the high design. So you see the big difference there is a community space in this playground that I'll get into. The playground was designed as modular pieces to keep it super simple. And then the big catchment is in the middle, which is enhanced infiltration, right? So it goes below the basically foot level and has additional like levels of rock in it. Because this is such like Navajo Road is such a high flooding case, right? Right. So some of the programming that the students are thinking of, you can see these different places. So the playground, a gathering place for community organizations, movement. So making sure like the children in the neighborhood have this safe kind of bicycle loop that they can bike around or run around, play around, which connects the basins. Here's some visuals of that central basin and some of the play structures and gathering areas. And then they had this strong idea of different vegetation zones, but also these activity zones. So strong pedestrian zone, an activity zone, and then this buffer zone to Navajo Road. And then you can see some of the different plantings that they're looking at across and the water flow across these different zones. Some more renderings. Safety, like I said, was really important thing that students thought about. So, change in material, classic, simple way to signal kind of safety or that cars are entering a different kind of area. Visibility was a huge idea too with the playground. And then also with these parks, stormwater parks, the students are asked to do at least one complete like set of architectural drawings. So it needs to be something like a shade structure a playground. And so in this case, they designed this playground and also like a community gathering area in terms of these sets of modules. And ultimately, this project, we have design build courses in the School of Architecture that's looking to build this project for Habitat for Humanity. So U of A will continue the connection with this project through another studio and another set of students that are learning then about construction. So there's some of the other this idea of modular parts. Students have to do a systems diagram for their project, and they can do this in all different sorts of ways to visually represent how the water flows across their site. And you can see also here how they're incorporating the numbers and calculations that they're getting from flood control in terms of those cubic feet of runoff, and the amount that's ultimately leaving the site as outflow, the advanced infiltration, that amount of storage in the different basins. So they're incorporating those numbers, as well as they need to make these sort of detailed sections that actually start to show what's happening in the ground between subsurface with the water. And then also they have to do a Sankey diagram for water, right? These are normally seen for energy flows. And they need to represent what's happening before their intervention on the site. So you'll see this, like basically the water coming into the site and then how it's leaving the site, and then after the intervention, and the different basins. You can see how they're kind of synced up to that ultimate storage capacity and that network impact. And flood control, you can see total storage gives them a 2-year event, a 10-year event, and a 100-year event. And they're asked to also think about these quantities in a different way. In this case, they're thinking of like what that means in terms of swimming pools, just to get their minds around the amounts of water that we're talking about here. I think lastly, and then I'll flip through the last 2 projects really quickly. Students are also asked to, in this idea of this high design and this low design, they're also asked to parse out their projects in terms of kits of parts, which is, the idea here is that whatever they're designing in this studio course setting, they need to think about how it could be used elsewhere in the city, right? So everything's not a one-off design, that they can break it apart and think about how these different parts could be used, in additional parks throughout the city. So you can see that here are different pieces: flood mitigation pieces, architectural components, and then the vegetation pieces. And then how they kind of put that together over on the right side, color coded, is kind of almost this kind of game board of insertions. This also helps them do a budget with, itemization and so forth, right? Which you can see here. Okay, so I'm going to flip through the last 2 very quickly. Howrah Court is, it's an existing site. You can see it here on the bottom of the screen. It's basically a industrial site right now. Semi trucks are parked on it, right?
Vacant
Jacob,
land.
What did you say?
Vacant land.
Yeah, it's a vacant land site. Nothing very attractive. This was a site I was like thinking maybe the students wouldn't select to want to work on this site, but it ended up, I mean, the coolest thing with the students is, it ended up as one of the best projects. I thought, like, really interesting. It borders a wash, and so you'll see that there. The students did an amazing job. These are some of the pictures, right, of when it's flooded. This site. Here's some of the topography and how Howrah Wash is going through. So obviously that wash is a big design determinant. And then they did a great job with community engagement. Both these students were Spanish speaking, and so they went into different community gardens. They're really interested in that. Talked to people, and then they also came upon this idea of tianguis, and that they needed a new site to do kind of like swap meet. So they had this additional overlay program that they identified, and then they did some community engagement. They did a survey to figure out where people would use the site for different purposes. So here's the design. It's this is the high design, and it's basically, you see that wash running along the bottom of the screen. I don't know if you can see my cursor, and what they've done, and then this low part, and then you can see in A and B these section cuts, right? B's here, A's here. up through these tiered gardens and these performance spaces. So this is a larger amphitheater performance space. Up here is where the tianguis can be, like, do the swap meet and so forth. And then there's different education spaces and another smaller performance space. Here's different breakout, smaller sections, and again, portraying the tiers, architectural drawing of structure that they created, and then how the water is moving across the site and the different tiers. In the case of flooding, their kita parts, their plant palette through the different tiers, right? Depending on how much water, the lower tiers are getting more water. And then some views of those performance spaces and play spaces. And here's the tianguis. And then this is lastly their systems diagram of with the numbers that flood control, ultimate numbers that flood control gave them, how that water is moving across the site. And then the storage represented for a 2-year event, the total storage, 800,000 gallons. So the last one, and then I will stop talking, is Francisco Elias Community Park. This is existing City of Tucson Park. The students were only tasked to use this very lower, smaller part of the park because there's other activities going on around this. One important thing about this park is it's also neighbors Tucson House, which is currently a HUD housing project. It's an existing, I think most people in Tucson know about that tower, but it's that currently has a HUD community neighborhood development grant. I don't know the correct terms. They're not coming straight to my head, but here are the issues that the students wanted to address. Of course, flooding, and then the unhoused populations on site, and then vandalism as a big issue. Here is the Flow 2D model and some photos that the students have. This project also has a wash going through it. And this is their answers to these issues. First, putting in a box culvert that puts the water from the wash underneath the road. Right now it goes over it and floods. It's important too because this 15th Avenue is slated to have a new bicycle boulevard to go over it. And then you'll see they have made new community spaces for the unhoused population. They had this idea of a community fridge that they put into effect. They identified this site as part of this larger Santa Cruz River green space network. And here's their site plan for their high option, where you can see where they've redirected the wash, put in several basins, and then put in this box culvert. And then you can see on one, this one is where the new bicycle boulevard that they've designed with some green infrastructure as well along the sides. Here's their flow diagram and their section cut of how they're linking also the basins into the wash, right? With these overflow opportunities, a new bridge, some more images of their ultimate design of the project, their architectural drawings, their kita parts, their high option rendering. And then lastly, here's the students also have to do a group project. And this year they get to decide whatever they want to do. And they really wanted to do a coloring book this year. So we have Where the Water Flows, which is a great coloring book with this rhyming narrative through these different parks in Tucson, re-envisioned with green infrastructure as part of them. So with that, I'm turning it back over to Jacob. So, thanks.
One thing we've added to our scope of work now, we're doing for the next 3 years, is a multi-objective site selection. So just like how we chose our MS4 watersheds using big data sets, we wanted to scale that down and see if we could fine-tune that process using our big data sets on what we have. And this is where we're teaming up with our friends at ASU, Dao Quinn Tong and Yang Quinn Zhang. They are producing a calculator, an algorithm, to see if we could take take the human out of selecting sites. Hard to say, but you know, the low-hanging fruit on site selection is going to run dry, and we have to be more calculated on how we pick our sites and demonstrate the site selection to the public. So this is it's a 3-year project. We just completed the first year, focusing on those North MS4 watersheds. We're going to take what we learned in year 1, apply it to year 2 with our new with our west watersheds, and see if we can expand on the process. And so what you're seeing here is some big data sets. They all get compiled into a composite score, and you can see that those highlighted parcels in the middle and then the circled ones on the right, they come out to be high score candidate sites. Nicole Casebeer and I have been talking, and she brought up a good idea. Maybe the selecting at the parcel right now it doesn't work. Could we scale it out and focus using the same process, but focus on neighborhood associations so that we could reach out to them and then get the conversation going. Another thought is this a ChatGPT opportunity? How do we get all this great data we have and put it into a calculator to find these best sites? Next slide, please. Okay, so what do the professionals get out of this? Well, I think it's inspiration and building the public trust. Our first project with Courtney's class, Courtney and her class came to flood control and asked for technical help. They said, we have this corner lot in Midtown, it's vacant, and there's stormwater. Could we make that into a community space? They called it Hydro Tetris. And I truly believe that first project was inspiration for our first stormwater park, Seneca. You could see it. They have some of the same qualities. Next slide. And moving forward, our friends at the city, they have Prop 407, I don't remember the number, but it's to build up and improve our city parks and pathways. We have 2 that are in the final stages of, I think, design, Jacobs Ochoa Park and Barrio Nepal Park. Though they are not following the designs that Courtney's studio have built out over the last few years, you do see some resemblance. Number 1, the Keynote 1 and Keynote A are the water harvesting basins, and there's some similarities. So we are getting these pretty pictures with technical support into the viewscapes of decision makers and the public, and I think it's a great value to us stormwater professionals to have these designs that are inspirational. And next slide. That's it. 4 o'clock. Thank you guys. I enjoyed working on this class. The students definitely have a great perspective on what they're learning something, and we're also learning something from them too. So thank you guys.